Hello and welcome. Today's lectures we are going to discuss the topic phenols. In these phenols, we have see the various types of reactions like first rearrangement, price rearrangement. When phenolic esters are heated with anhydrous aluminum chloride, they undergo rearrangement in which the acyl group migrates to the aromatic ring with the formation of orthophenolic ketone as the main product. If ortho position is blocked, then reaction can take place at the acyl group migrate to the para position predominantly. This rearrangement is called price rearrangement. Okay, price rearrangement means these acyl group. This acyl group, it will be migrated to this ortho position. If ortho position is blocked, then this migrate to the para position are here in presence of aluminum chloride. This is called price rearrangement. So product is, this is A, acyl group migrate to aromatic ring with the orthophenolic ketone. Orthophenolic ketone as the main product and paraphenolic ketone. If this point reaction when happen, this point means this position is not blocked. If this position is blocked, then the acyl group, they will be migrate to the para position area. So we have see the application of price rearrangement. These rearrangements which are helpful to the preparation of aromatic hydroxy ketone to the orthoisomer can be separated from para-isomer by steam distillation. So first application now we have see are here. So preparation of N-hexyl resorcinol, and these N-hexyl resorcinols are the antiseptic drugs. So how will you get this form? In presence of zinc chloride, what happens? The lone pair of that oxygen is attacked and replaced by this OH. How will you replace? Replacing OH is converted to good living group as a Cl, is attack on this carbonyl carbon and replace OH in the Cl. And to get this chain which is attached to the oxygen atom, then what happens in presence of zinc chloride by heating conditions, these group or these chain, they will be migrated to the para position are here. Then after migrations, what is the first step? First step, it is a acylation reaction. Next step, it is a price rearrangement reaction. What is mean by price rearrangement? The rearrangement in which the acyl group, this is also one of these acyl group will be migrated at which position? It is ortho position or para positions. So we have prepared this N-hexyl resorcinol. So this chain or this group will be migrated at para position here. Then after migrations, by using zinc amalgam in concentrated HCl, what is the role of zinc amalgam in concentrated HCl? Are the reduction, means carbonyl group, they will be reduced to corresponding alkane, like carbonyl group is replaced by the alkane. So you can understand it the zinc amalgam in HCl, which is act as the good reducing agent for carbonyl group, is converted to the alkane. So these zinc amalgam in HCl are used for convert carbonyl compound to alkane. Next applications, we have see the preparation of gamma substituted acetophenone. This catechol we can treat with the chloroacetyl chloride. Then what happens? This lone pair of that oxygen is attacked on this carbonyl carbon and this Cl will be replaced. To acetylation can take place at this oxygen atom. Then after we have add this aluminium trichloride in carbon disulfide. Then this group will be transferred or the migrated to these para positions to this catechol. And to get this is a final product. Next rearrangement, we have see the Claisen type of rearrangement. These rearrangements are the allyl aryl ether heating at 200 degrees centigrade. They undergo rearrangement reaction to form allyl phenol. It is a intramolecular rearrangement reaction which is called as the Claisen rearrangement. Means that it is a Claisen rearrangement means this allyl or allyl aryl ether, they will be heated at 200 degrees centigrade. They undergo rearrangement reaction and to form allyl phenol. Means this allyl group, they will be migrated to these positions, ortho positions. This is called as Claisen rearrangement. In this reaction, allyl group migrated to ortho position and to form ortho-allyl phenol. If the both ortho position like this position and this position will be blocked, then this allyl group is migrated to the para positions. So first reactions we have see is here. This allyl group, it will be migrated is this carbon. How will you migrate? After attack on this, bond is transferred to this carbon-carbon double bond transferred to here, and this carbon-carbon double bond transferred to here. Then after formation of carbonyl with this aromatization and to get this ortho-allyl phenol as the product. Next reactions we have see is here. In the reactants, the two ortho position they will be blocked like this ortho position, and this is also ortho position will be blocked, and hence this is a Claisen type of rearrangement. The allyl group they will be migrated to the para position. See here in the products we are see this allyl group will be migrated at the para position are here. The reaction does not require any catalyst for the migration of group at ortho position can take place at gamma carbon only. The allyl group with respect to oxygen atom to get attached. The para migrating can take place in two stages. First stage is ortho migration and second stage is a rearrangement in unstable intermediate which protons shift and to leads the ortho-allyl phenol will get the products. In these reactants we are see is here, it is a alpha carbon, this is beta carbon, and this is a gamma carbons. So this is a gamma carbon After migration, what happens? This gamma carbon is attached to ortho position, right? This is a gamma carbon. So this gamma carbon is attached to ortho position. See here, this is a gamma carbon is attached to ortho position, and then after aromatization, like this replace of protons to form carbon-carbon double bond is here, and this forming the negative charge is here. This negative charge abstract the proton and to form OH, like the keto-enol tautomerism reactions. Means it allyl phenyl ether, it can be migrated to this ortho position that times the gamma carbon atom in the allyl group can attach to ortho position with respect to oxygen atom. The migration has been confirmed by using tracer technique. If a alpha carbon is labeled by isotope like a carbon 14, the non-labeled carbon atom gets attached to the ortho position, and if para-migration labeled carbon is attached to para position. Where C is here, this alpha carbon, beta carbon, and this is a gamma carbon. This alpha carbon we can labeled as the carbon 14th isotope. Then after migration can be happened, we are C is here, the labeled carbons which gets attached to ortho position, and if para migrate labeled carbon to the para positions. So these tracer techniques we are shows that which carbon is attached to ortho position and the para position. If ortho position can take place, this labeled carbon which is not attached to the ortho position. C is here. This labeled carbon does not attach to ortho position. Okay, this labeled carbon is free from attachment. So this number of reactions we are see is here. This is a alpha carbon, beta carbon, gamma carbon. So after migration, what happens? This ortho position is attached to this carbon is here. So gamma carbon. आपण आत्ताच बघितलं की gamma carbonचं फक्त attachment होते. So this is alpha carbon, beta carbon, and this is a gamma carbon. So gamma carbon attach कुठं होईल? इथं ortho positionला. झालाय का इथे ortho positionला? Gamma carbon attached to, and this is the methyl group are here, and then after formation of carbon-carbon double bonds. Similarly, other reactions, the ortho position is block is here, and therefore these allyl group will be migrated at para positions. So which group can be attached? Alpha, beta, and gamma carbon. So how will you attach? First migration is gamma carbon and second migration is a alpha carbon. So alpha carbon is attached to the para position. Similarly, these group alpha, beta, and gamma. So at ortho position, the gamma group is attached. The gamma carbon is attached is here, ortho migration, and para migration we are see is here. Both position they will be blocks, right? Which position? This is a ortho position and this is also ortho position. Both positions will be blocked and therefore this group will be migrated at para position. But by using tracer technique, we are confirmed that which group will be attached at para position and which group is attached to the ortho position. If ortho migration can take place, the gamma carbon is attached to ortho position, and if the para migration can take place, the alpha carbon is attached to the para position. So by using this tracer technique, we can confirm which carbon is attached to which position. Okay, thank you.